Hello. So today we will do another solving session on vibrations and waves. So let's consider the following example. A block of mass M attached to a spring of stiffness K equal 500 Newton per meter oscillates in simple harmonic motion. The oscillations are recorded as a function of time in the adjacent figure. Okay, so we have X as a function of time. What is the position of the oscillator at t equal to 0? So I go to my graph, and at t equal to 0, I can find that x is equal to 0. So determine the amplitude of the oscillation. So the amplitude, I get it from the maximum value. So the amplitude is equal x maximum, which is 0.06 or 6 centimeters. Determine the period t of the oscillation. So it's from 0 to 1. So this is the period 1 second. Reduce the value of the frequency. So the frequency is 1 over t. So this is 1 hertz. And the angular frequency, so omega, it's 2 times pi times f. So it's 2 times 3.14 times 1, and this gives me 6.28 radian per second. Okay, deduce also the mass m of the attached block. So we use omega square root of k over m, or omega square equal k over m. So omega, so m is k over omega square. Just put the numbers. K is 500 divided by omega square, which is 6.28 square. And this gives me 12.68 kilograms. Find the position of the block at t equal 0.75. So I come here at 0.75, so it's exactly in the middle, okay? And we want to deduce its speed. So find the position first. So the position, it's from the x-axis, it is 6 centimeters. So this is part E at t equal 0.75, x equal 6 centimeters. This is part E equal 0.75 seconds. X equal 0.06, which is x maximum. And deduce its speed at that time. So since it's at maximum, implies v is equal to 0. We have to remember these things. At x maximum, the mass will stop and goes back. So v will be equal to 0. At what positions is the speed equal to 0.3 meter per second? Okay. So let's do it here. At what positions? So find x. So the question is find x, 1v equal 0.3. Okay. So here, this is not a particular value. This is not at x maximum or at v maximum. Or at x0 or at x equal minus x maximum. So this is at any x. So here I have to use mechanical energy at v equal 0.3 is equal to mechanical energy at x equal A. Okay, always use on the other side mechanical energy at x equal A. So what is mechanical energy at V equals 0.3? This is kinetic energy at V equals 0.3 plus EPE at V equals 0.3, and this is equal. What is happening at x equal to A? There is only EPE because there is no kinetic energy. The kinetic energy is 0 at that value. Okay, so this is EPE at x equal to A. Now let's plug formulas. This is half mv squared plus half kx squared equal half ka squared. Okay. And now I just plug whatever values I have. So the half and the half and the half cancel out. I can just delete them from the whole equation. Okay. And I found it, it's 12.68. V is 0.3. K is 500. X is my unknown, K is 500, and A is 0.06. Okay. Now this is just a mathematical equation. So 500 times 0.06 squared is 1.8. And the 12.68 times 0.3 squared is 1.1412. So I will have 500 x squared is equal to 1.8 minus 1.1412. 500x squared is equal to 0.66. X squared equal to 0.66 divided by 500. X squared equal to 0.66 divided by 500, 1.32 times 10 power minus 3, or x is equal to, so now I have x squared is equal to a number. It means x squared is equal to a number. It means x is equal to plus or minus the square root of that number, which is 0.036 meter, or we can put it in centimeter. X is equal plus or minus 3.6 centimeters. So at x equal plus or minus 3, at x equal plus or minus 3.6, which is almost here. So this is 3, this is 4. So 3.6 is almost here. So at this value and at this value, we have V equal 0.2. Okay. So that's it for today's lecture. Bye-bye.